Hello everyone, today I'm going to be taking another look at the shader just to explain things a bit more, because I believe that the way I explained it wasn't quite good. Okay, so we had a basic shape which was a quad, and this quad is composed of two triangles. Okay, let's make this a bit thicker, like that. Okay, by default the way things work is that the image we want to render on that quad is adjusted to the size of the quad. Okay, that's what we call UVs. Okay, UVs are vectors for each of the vertices, like every corner here. In each of the corners of the quad we have a vertex. Okay, so first what we wanted to do in the shader was to render just one of the sprites and not all of them. So when we program shaders, for the basic shaders we have a vertex shader and a fragment shader. The vertex shaders can control the UVs here, which then are passed to the fragment shader, which is the one who does the color. Okay, and the vertex usually handles position, the scale of each one of the vertices, the UVs, etc. So in this case, since we only wanted to change the UVs, we use the vertex shader. Okay, and left the fragment shader as it was. So if we see here on the left side, we have this shader. The first thing we did was to make it transparent. Okay, we used these tags right here, which I found on the internet. This one is the one who does the transparency itself, the blending. Okay, this is what's called an alpha blending, which is that if you have a semi-transparent object which has a 20% alpha, it will take the source alpha 20%, it could take that 20% alpha and the 80%, 100 minus 20%, 1 minus source alpha, that's an 80%. So it will take 20% color of this image and 80% color the background, and that's how this blend works. Okay, so then here we have some code that comes with Unity. We have here our vertex data called app data. Unity's default naming. Okay, here we have the vertex position and the UVs, which are the texture coordinates. Okay, like these corners here. Then the information that we pass to the fragment shader is the V2F, vertex to fragment. We pass the texture coordinate and the vertex position. These are the variables that we are using in our program. Okay, the current frame, the rows, and the columns of the image. So here, in the fragment shader, we just take the texture point for that particular UV and draw it. So if we have to draw this pixel, we just take that pixel and draw it on the screen. Very simple. In the vertex fragment, we had to change how the UV works. So what we did was to, coming from these big UVs, what we did in the first place is to divide the X by the number of columns. So we had something like that. And then we divided the Y coordinate by the number of rows to have something like just a single sprite. Okay. Then we took the frame as an integer and calculated the X and Y offset, because we wanted this to be the frame 0, 0, 1, 2, 3, 4, 5, and so on. Okay, so for each frame we took the X and the Y using the column. So once that we know the X and the Y of the frame, we can use any one of the images here. Since the way it worked was a bit complicated, I did some adjustments here. These 3 lines here are this line here, what I did was to shift the way the Y worked, because the first row that it took was this row here. So I added another row, so it starts from here. Then since the Y goes from bottom to top, I use this minus to make it go from top to bottom, like that. So this is the row 0, the row 1, the row 2, and the row 3. And then the X coordinate worked fine. So it starts from here to here to here. And since the UVs are between 0 and 1, whenever we make something bigger than 1, for example, if we have 1.2, it's the same as having 0.2. Again, 2.3 would be the same as having a 0.3. And that made we had these sprites here, okay, that we can use this frame to change. Okay, sorry about that. Okay, this frame can be changed. As you can see, the sprite is moving, and since we use the frame as an integer, we can see the sprite not having like several fragments or just splitting, something like that, just because we used integers instead of floats. So why did we make a custom shader? It's because I want to implement a custom lighting system down the line, because I feel like having the means and the tools to work with your own lighting could make a better game. So that's why we will be doing some more work on this shader later down the line. And that's it. Have a nice day.